Right, good morning, everybody. Are we all ready and connected? Earphones on, all of those type of things? If you can comment for me, yes, if you are online, please. It's been a week since we have last chatted with one another. A lot has gone by, a lot has happened, and I trust we are all ready for today's lesson. I'm just hearing from the kids in Richards Bay if they can hear me, so please bear with me. Today we will be covering scales, which is numerical scales and graphic scales. I gave you work to do last week, and we shall go through that after the first break. I'm still waiting for everybody to know if they can see or hear me. It is a little bit slow to start in the morning to get everybody up and going and connected, but I'm sure we can get everybody online soon. A very quick recap of last week. We did maps, how to read a map, how to get yourself or find yourself where you are situated in a floor plan, find out where shops are in a mall. Activity 25 and I think it was 26 needed to be completed today, which we will be doing as well. I can't see that anybody is telling me that they are connected, so we're just waiting for them to connect and then I will carry on from there. We had layout plans last week, which we covered in detail. If any of you don't understand it, please go back to the video of last week Thursday and you will be able to listen to that again. I know some of these maps are a little bit small on your screen. You have the textbooks available to you, so you can go through the actual textbook. This is just an uploaded version so that we all can see what we are working from. Okay, they've just let me know that they are not online yet, so I'm just waiting for them to come online, and I've told them where to find the feed. If you are already on this feed, then you obviously don't have to find it, but you can go to Cairo Education on the YouTube channel. and look for the current live broadcast, which is then Math Literacy Grade 10 to 12. Grade 10 to 12 is very similar to each other. In Math Literacy, Grade 12 just covers a little bit more, which you will see in the later parts of the broadcasts. I can see that nobody is online, so I will just be waiting for everybody to get online. Okay, I've just got notice that two of the students are going to help the others to get connected. Thank you very much, Lucas and Jasmine, for helping the others. Please, can I get a thumbs up from everybody that you are online? Okay, Lucas, Jasmine, can one of you let me know if the others are connected, please? You must please subscribe to this channel as well in order and log in order to comment on it. Okay, so on the Math Questions to Live WhatsApp group, can everybody please tell me that you are online? Lucas has said that he's online, and I will take it that Jasmine is online. NK, thank you. I'll give you some time to sign in. Lucas has again said he's online. Okay, where is Whitney? Where is Artie? All of those people I can't. Okay, if you can't sign in, it's fine. We will speak here if you have any questions from here on further. That is completely okay. I can then carry on, right? Is that a thumbs up for me to to proceed. Okay guys, if you go, I'm going to listen to voice note quickly. Okay, I've just been told Whitney and Artie is not there, so it is okay. We'll carry on with the lesson, and they can stream it from home. Okay, so I want you guys to go to Unit 6. It is available. Sorry. It is available over here. Sorry. I'm just trying to get it available for you guys. 1 second, please. Okay, looks like we have some trolls this morning. But it's fine, we will get there. There we go, now we are ready. So, today we are going to be dealing with the lesson of scales. Now, scales can be, it can either be a scale that you measure weight on, or it could be scales on a map. Now, seeing that we have been doing map work, etc., etc., this is what it will be pertaining to today. So, if you see, I'm just going to put my hand back here. If you see this on a map, firstly, that is called a scale. Alright? It is 1 unit equals to another unit. So, if this was 1 length of measure equals then to 100 lengths of this measure. Okay, so if we were to take this pen and use this as our 1 unit of measure, that would mean if I want a realistical length, I would take this and I'll go 1, 2 and a quarter is the length of this paper. Then you would take 2 and 1 quarter equals to what? You will multiply 2 and 1 quarter by 100. Okay, because 1 unit equals to 100. Okay, are we all there? I'm not going to work out this fraction now. I will be doing fractions a bit later as well. Okay, so 1 equals to 100. Now we go back to our window capture. Being able to read and apply map scales is an important skill. It is equally important to be able to describe the position of the place, like your home or your school, in relation to your surroundings. If your friend wants to visit you, you need to be able to give them instructions on how to find your home. Example: turn left at the traffic light, past the first street, etc. Now, if I have to give you directions on how to get somewhere, I'm not going to say, you know what, you drive a little bit forward, you'll pass a couple of roads and then you will turn left. You will carry on again for about 4 or 5 roads, then you will turn right. That is the incorrect way of giving directions. What you would do is say, I am in Soap Street. Once you get to the robot, you will turn left. Once you have turned left, you will travel for approximately 700 meters until you get to the following robot. At that robot, you will turn left. It is Creek Street. From Creek Street, You carry on until you hit 2 speed humps. You will get to a 4-way crossing. Cross the 4-way crossing. Once you get to the following stop street, turn left into James Avenue. My house will be the third house on the left, and it has a black gate with a big green number on it. This is how you give proper directions to somebody. You use landmarks in order for them to visualize what they are looking for. A map scale is a ratio of the distance on a map a map scale is ratio of the distance on the map to the distance in reality. A map scale is 1 to 10,000. The distances on the maps are 10,000 times smaller than they are in real life. The map distance of 1 centimeter per millimeter therefore represents 10,000 centimeters per millimeter in real life. We can also say that real life is 10,000 times bigger on the map. It's just what I've shown you on the piece of paper. You have this pen. If you measure it, the paper is 2¼ times bigger than this pen. There are 2 types of scales, numerical and graphic scale. What is the difference? First of all, we are going to deal with numerical scale, which is a digital scale. A numerical scale is expressed in numbers as a ratio. For example, 1 to 250,000 or 1 to 14,000. In reality, it means that 1 centimeter equals to 250,000 centimeters, or 1 millimeter equals to 14,000 millimeters. We can use this formula when we have to convert map distance to real distances. Now, in your math book, please, your hard copy book, I want you to please draw this big block. Remember to mark it as scales, the date the 22nd of the 4th 2021, and then I want you to draw this formula for me, please. Once you've done that, please let me know so that I can carry on. So, what is the formula? Real distance equals map distance times map scale. They will most likely give you this in the test, but it is good for you to memorize this information, as it is not always given to you in the test. Okay, how are we doing? Is that done? Okay, so now you've written that down, we are going to follow a few examples. If the map distance measured with a ruler is 15 centimeters and the scale is 1 to 500, what is the real distance in meters? Okay, so we are going to go to, if the map distance measured with a ruler is 15 centimeters and the scale is 1 to 500, we have the information. Alright, what do we do to work this out? we have just got a formula. Real distance equals map distance multiplied by map scale. Okay, so now all we have to do is put in the information. So that will be equal to 15 multiplied. Why have I put in 15 here? It's the map distance measured by the ruler. Okay, so it's 15 centimeters multiplied by 500 equals, you will never work this out in your head unless you go 15 times 5 is 75. Add your 2 zeros that were left over. So it is 7,500 centimeters. Convert that to a smaller amount, okay, because you always want an end result and a simplified answer. So that will then be 75 meters. Remember that 1 meter is equal to 100 centimeters. Okay, there I've just worked it out for you, and as you can see, the answer is the same. Find the real distance in kilometers between two towns if you measure on the map as the crow flies. The distance is 20 centimeters on the maps, and the map scale is 1 to 20,000. Okay, so what is as the crow flies? You cannot go and measure exactly. So as the crow flies means over bushes, over roads, over everything. Alright, it's an estimate answer that you're going to give to them. So you take your piece of string or you take your ruler and you measure this to get your answer. Again, it is 20 that they've given to you here, multiplied by 20,000, which they've given you here, equals to 400,000 centimeter. 1 kilometer equals 100,000 centimeters, and 1 kilometer equals to 1 million millimeters. Okay, so where are you going to simplify this to? 1 kilometer equals 100,000 centimeters. It's on 400,000. You divide that by the 1,000, you'll get 4 kilometers. Okay? Are we all with? Do we all understand? Okay, it says, find the distance if the real, find the map distance if the real distance is 25 meters and the map scale is 1 to 100. Okay? Same as before. You put in the information that's given to you. I am going to give you this one on paper. Okay, your formula says, okay, so the real distance equals the map distance multiplied by the map scale. Okay, now they've given you the real distance is 25. The map distance they did not give you. And the map scale is 1 to 100. Okay? All you have to do now is simplify your answer. Here is a multiplication. If you take the 25 across, it becomes equals 25. That multiply becomes a divide by 100 equals 0.25 meters. And that equals to 25 centimeters. Okay? Do we all understand that? Are we all ready and together? Can I move on? Today it feels like the class is very flat. Okay. The layout plan of schools given with a numerical scale. Why is it given with a numerical scale? Because it is square, definite blocks. Okay, it is something that you can easily go and measure. If you remember last week we showed you the trundle. That would be sufficient use of the tool to go and measure this. Now it says this scale above is 1 to 500. It says find the dimensions of the sports field, length and width. Hint, first measure the length and the width of the sport field with a ruler. Okay? Why are we measuring this with a ruler? Because we are working off a physical map in a book. If you were at the property and you were measuring it with the trundle and you want actual measurements, that is when you will use the trundle. Because we are working from a book, this will be an estimate. I also want you guys to know this answer here is going to be different because we have loaded it onto the computer and the zoom is incorrect. So I am not going to do the exercise of actually measuring this because it's going to be incorrect. The book is in class. You guys can go and have a look and measure it and you will see that this is the correct measurements. Okay, so find the dimensions of the sports field, length and width. Now we go up. Oh, there's the sport field. We measure the length and we measure the width. Okay, here it says the width measured is 4 centimeter. Length, the real length is 8 centimeters. So you take 8 centimeters multiplied by 500 equals to 4,000 centimeters equals to 40 meters. Real width, 4 times 500 equals 2,000 centimeters, which equals to 20 meters. Okay, are we all understanding? It's really basic. All we're doing is we are taking our formula given to us, we are putting in the information that is given to us and that we measure, and we will come to an answer, and then we simplify it into meters. Alright? Now we get something called a graphic scale. If you look at the graphic scale, you would see all these little breakdowns of scales. Okay, of the entire scale. Then you will get the bigger one. Why do they do that? Why do they break it down into smaller parts? Okay, the reason for that is so that it is easy to estimate your answer. So if you look over here and you have a piece of string that is just the length of that, you can more or less say it is 1 meter long. Okay, a graphic scale uses a bar consisting of blocks to show distance. Each part or segment represents a particular distance. Okay, here we go again. There are 2 segments to this. Why is it like this? So that you can easily gauge on what it is. Okay, what size portions there are that you need to work with. How do you use a graphic scale? Take a ruler and measure the length of one segment of the graphic scale. Okay, so that would be, one segment is from here to here. Now measure the straight line distance between the 2 points. From here to here. Calculate how many segments are divided into the measured distance. So We've measured from here to here, and then we've measured from here to here. Alright, count how many segments there are. There are 2 in this one. Okay, if we go a little bit up, you will see in this one there's 2, 4, 6, 8, 10, 12 segments. Alright, so just make sure that you count your segments correctly. Multiply the number of segments by the given scale to get the real distance. Okay, so for example, we're going to this one. Okay, this one over here. If 1 centimeter on the graphic scale is 10 meters in real life and the measured distance on the map is 3 centimeters, you will take 3 centimeters divided by 1 centimeter of the length of the segment. So there will be 3 segments. Then the real distance is 3 times 10 meters equals 30 meters. Okay? All with me, all together, all understand. You guys can go over this a little bit later as well. I will give you enough time. Okay, then it says study the floor plan and answer the questions. Okay, this is the floor plan. As you know, it has the various markings as per our previous lessons. Use the graphic scale to determine the real length of the bookshelf. Okay, again, we can't measure it. Where's the bookshelf? We can measure it here, alright, but it's not going to give you a true reflection of the actual measurement, because this has been blown up and made bigger in order for this purpose. So the length of the scale, 15 millimeters, equals 40 centimeters, or 1.5 centimeters equals 40 centimeters. The length of the bookshelf, 45 millimeters or 4.5 centimeters. Okay, then it says 1.5 centimeters equals 240 centimeters. Where are they getting this 1.5? Where are they getting that 1.5 centimeters? They've taken their ruler and they've measured the length of the bookshelf. So 4.5 centimeters equals to what? Right, here's the operation. This is how we work it out. 4.5 centimeters, which is here, multiplied by 40 centimeters, which is here, divided by 1.5, which is here or there, equals to 120 centimeters. The length of the bookshelf is 1.2 meters. Alright, can we all tell? Can you let me know if you are all with me? Okay, then it says find the real length of the smaller sofa. Okay, so again, 1.5 centimeters equals 40. The scale 1.5 centimeters equals 40 centimeters. Length of the smaller sofa is 3 centimeters. So they've measured the sofa, which is 3 centimeters. So operation, 3 centimeters multiplied by 40 centimeters divided by 1.5 centimeters equals 80 centimeters. Okay, so the length of the smaller sofa is 0.8 meters. What are the advantages and disadvantages of the scale? Advantage: you only need to calculate one distance. This is the numerical scale. This is also known as the ratio scale. So you only need to calculate one distance. Therefore, it is easier to do the calculation. If the size of the floor plan or the map changes or increases, the scale is no longer accurate. This is exactly what I explained to you just now. We have zoomed this for lesson purposes, as soon as you start zooming it, it is no longer accurate. Okay, and that is why I'm saying go to the book. The book will give you the accurate measurements. If the size of the floor plan or map changes, now this is a graphic scale. This is the scale that we spoke that has the partitions. Okay, if the size of the floor plan or the map changes, the map will change proportionally and the scale will remain accurate. Okay, again, as it goes bigger and smaller, obviously this will grow bigger. However, for this purpose, it is grown bigger, and there are examples, so the answers of this will not get to the same as what's in the book, and therefore I have not done an example for this reason. The disadvantage of a graphic scale is you will have to measure very accurately to do more calculations to find the distance. Okay, as you saw here, this is a lengthy process to work this out, whereas if you go to this scale, it is as easy as that. Okay, you can see it's a much smaller calculation. Are we all with an understanding? Okay. Has everybody done activity 27? Okay, Lucas, can you find out for me if anybody else did it? Okay, so it seems that everybody did do the work. If you look at this one here, what kind of scale is used here? Lucas, tell me what is used here. Fantastic, Lucas, thank you. And what do we call the other one without scrolling anywhere? What do you call the other one, Whitney? No, Whitney's not there. What do you call the other one, Jasmine? Okay, every one of you, your activity 26 and 27, I want you to please give it to Sir Herman, and just ask him to scan it and send it to me so that I can mark it and then give you feedback on that. Lucas has given me a voice note again. Thank you, Jasmine. It is a graphic scale. Okay, so guys, I think we have made some progress on this. We are done with this section. We are moving on to probability in a second. Let me quickly get there. There's probability. I want to know if everybody understands map work. It's going to be this term. It's going to be a big part of your exam and your lesson, so you're going to have to understand it. Nobody sent me a message or let me know that they don't understand, so that I can give them some extra classes. So I am taking it that everybody understands. So you have the chance now to tell me you understand or you do not understand, so that we can take it a bit further. Thank you, Jazz and Lucas. Can you please list to me who is in the class? Because I'm trying to keep my focus on who's in the class, and I don't want to mention names that are not there. So as far as I know, that it is Wiz, NK, Wiz, Lucas, and Jasmine. Is this correct? Hello, Cairo. Thank you for that message. Okay, NK says he's been commenting on YouTube. Let me quickly have a look and see if I can find you on YouTube. Yes, NK, thank you. That is right. You say that it's numeric and non-numeric. Okay. In theory, that is correct. Alright. However, you're going to have to say graphic scale. If you say non-numeric, it is not going to be right, because there are still numbers involved. So you're going to have to say a graphic scale with the broken down segments. Okay. When you have a moment a little bit later, I want you to please ask Uncle Cairo, so that we can Skype, so that I can do some extra classes with you. I do understand that you are not understanding, so I will do that with you a bit later. Okay. Any other questions, guys? Any other questions? Okay, NK, I have seen your comments on YouTube. You can carry on commenting on the WhatsApp group, because we are all there, and not everybody is signed in. So, yeah, please comment on the WhatsApp group. I'm sorry for the inconvenience. Okay. So we're done with Unit 6. I am satisfied that everybody is understanding that. So now we are going to probability. I want you to put this in as a new heading in your book. Cairo is taking over the feed. He's saying that it's not healthy for Inge to cry like that, but we will leave it at that. Okay, so I want you to start a new page on your math book, alright, and I want you to write big Unit 7 probability on that book, please. Okay, are we all ready? Not listening to Sona, you are listening to me. Okay, Probability can seem very confusing to you, and probability can confuse you. I do not want you to get math nerves or anything of that measure for this. Alright, I want you to please stay calm and make sure that you read in a question that it says to you, what is the probability of this matter? If probability is used, then you will use this formula here. Okay, so once you've written probability in your book, this you need to write down as well. Okay, few things in life can be determined with certainty. We generally make predictions and say things such as, I am sure this will happen. She only has a slim chance of winning the competition, or it will definitely rain next week. Each of these statements is a prediction or something that may happen in the future. We talk about probability or chance that something will happen. This cannot be predicted with certainty. Probability can be written as fractions, decimals, or percentages. So, if I have to just quickly break that down, there are 4 people that are all running a race. If they all run, the one doesn't have shoes on, the one doesn't have can't run, the other one has some form of disability. What happens then? You say they have 1 in 4 chance of winning the race. Okay, or 1 in 4 chance of finishing the race. It all depends on what they ask for in the probability. Okay, that is how you write it as a fraction. Now if you take, I'm just quickly going to put my hand back here. Okay, so I've just said there are 4 people. There are 4 people running a race. Okay, so there's 4 out of 4 people, right? But now each one of them are running to try and get a chance to win. So you have a 1 in 4 chance of winning the race. This is written in a fraction. Now you want to write that in a decimal. Now you always know there's 100% people trying to win the race. Okay, so 4 out of 4, 4 over 4. So there are 4 contestants running the race. What is the probability of one of them winning the race? Then you take 100%, you divide it by 4, so they have a 25%. They have a 25% chance of winning the race. Okay, that is a percentage. Now you have to put that in decimal. There's your decimal. Now that percentage is also known as 100. So you divide that by 100 and your answer is 0.25. Okay? Do we all understand? Are we all with it now? Okay, so I've written it as a fraction, I've written it as a decimal, and I've written it as a percentage. Okay? In the notion for probability, where A refers to an event, okay, so A, can you all see that? A refers to event, and it's equal to the number of favorable outcomes. We've all written that, right? Over total possible outcomes. That's a U. Okay? Right? Okay, but Wiz isn't understanding. So I said he needs to set up a call or something. Is it because he's not focused, or is he not understanding? Okay. Wiz, please put down your phone. I am not going to give you extra time if you are not listening to what I'm saying. Right? Okay, guys, this is something that you have to understand in order to get the answers to. Okay, it is not easy, but once you grasp it, you will understand it. I just want to get my mouse down. Okay, so is the notion of probability where A refers to an event. For example, we will write a probability that a coin has been tossed in the air and land on heads as P heads equal half equals a 50%. Okay, why is that? You have a coin. How many sides does a coin have? It has 2 sides. If you flick it up in the air, you are going to have a probability of 2 outcomes. You're going to have heads or you're going to have tails. So the probability of hitting heads is 50%. Okay? Is 50%. I'm quite upset that Wiz isn't listening to me. He's one person that should be listening and he's not listening. Okay. Important terminology, which I want you to please write down in your books. Probability is the chance or possibility that something will happen. Okay? Probability is the chance or possibility that something will happen. So, in general conversation, someone will tell you, oh, you know what, I'm getting $10,000 tomorrow. And the person that is listening to you will say, ach man, what's the chances of that happening? Alright? That is probability. An event is a collection of one or more outcomes of an experiment. Okay, so now you've got physics, you are doing an experiment, you take Enos for example. Okay, now you have 2 glasses and you've got 2 bags of Enos. For the first one, you put the Enos in first, and then you put the water in. For the second one, you put the water in first, and then you put the Enos in. What do we know can be expected? What do we know can be expected in this? Number one, the one with the Enos in first. You will never know how much water you put into this Enos because there is a fizz already. The reaction starts taking place from the very first drop of water that's put into the Enos. The other one, you can fill it with a little bit of water, and you know once you put the Enos in, you have this much time to swallow it, and it will not fizz over. An outcome is the result of an experiment. Okay, so what is the result of the experiment I spoke about earlier. You had the 2 glasses of Enos. The result of the first one, where you put the Enos in first, was a mess. Because you put too much water in, the reaction started happening quicker and it fizzed over, and you did not get the required effect off the Enos. The second one, what was the result? You could drink that with ease, and you could enjoy the Enos and allow the reaction in your tummy to happen. Okay? Has everybody written that down? Wes, I am glad that you are actually online and listening to me. Please know that if I may go offline very abruptly in a moment, you guys can carry on with this if I do go offline. I am expecting someone to pop in soon. Okay. A probability scale is used to measure the outcome of an event. The probability scale is only between 0 and 1. An event could be placed somewhere on the scale. Okay. So, please hold on for me a second. I'll be with you now. Okay, so probability scale is as follows. If you look at the graph on top, the bar on top, whatever you want to call it, in words you write impossible, improbable, uncertain, probable, and certain. In decimals you write 0, 0.25, 0.5, 0.75, and 1. As a fraction, you write it 0, a quarter, a half, 2/3, and 1. As a percentage, you write 0, 25, 50, 75, and 100. Are we all with me and all understanding? If you look at these percentages here, or these decimals, fractions, and percentages, they are all equal to one another. Alright? So if you write down 0.5 uncertain, alright, that would still be, there's half a chance of having it happen, or finishing it, or whatever the probability is that you're working on. And there's a 50% chance. Okay. Now the example is, the next baby to be born will be a girl. Unless you are God, you cannot know this. You will never know if the next baby born will be a boy or a girl. Okay? So, how do you write down this? Now you sit and you figure out, if anything else, you have to sit and think realistically to yourself. How many sexes are there in the world? There's male and female. Okay? So there's a 50% chance that it will be a boy, and 50% it will be a girl. So, your answer will be here, 50% chance, or 1/2, which is still a half a chance, and 0.5, which is still half a chance. A triangle has 3 sides and 3 angles. Certain, your answer will be certain, or 100% chance, or 1. Alright? It is all written differently. You know a circle has 3 sides. The probability of that is 100%. You know it for a fact, and you can prove that it has 3 sides. Whether it be oblong, whether it be long sides, short sides, whatever the case may be, if there are 3 sides to this object, it is a circle, and if they are all joined, it is a circle. So the probability there is 100%. You can do various experiments to do probabilities. Okay, we've spoken about flip a coin. Okay, let's go back there. A coin has two sides, heads and tails. In other words, there are two possible outcomes when you flip a coin. It can land either on heads or tails. If you flip a coin twice in a row, you will get the following results or outcomes. Heads with heads, or heads with tails, or tails with heads, or tails and tails. Okay, I will be back with you shortly. Please give me a break. Go through this again. I will be with you in a second, okay? Okay guys, I'm back. I do apologize if there's going to be noise in the background. My dog is probably going to make a noise, so I apologize in advance. Okay, so this may confuse someone, okay? But if you read carefully, it gives you the answer. If you flip a coin twice, hold on. If you flip a coin twice in a row, you'll get the following results or outcomes. This here shows the first flip of the coin. So you'll get heads. Okay? The second flip, you may get heads again. Then a different outcome is if you flip and you get heads, and you flip again and you get tails. Now you flipped again, you get tails. Then you flip again and you get heads. Then a different one, you flip and you get tails and tails. These are 1, 2, 3, 4 different probabilities of the outcomes of flipping a coin. Okay? So, therefore, There are 4 possible outcomes. The probability of the coin landing on heads first can be written as follows. P, open your bracket, landing on heads first, bracket. So the probability of landing on heads first will be, because we've just said there are 4 possible outcomes, you have put 2 out of 4, which is also equal to a half, which is also equal to 50%. 2 of the 4 outcomes has heads as the first result. Okay, how do you know that, ma'am? If you look over here, 1, 2. Okay. The probability of the coin landing on heads in any other order. P, landing on the head in any other order. Okay, so the probability of what the question was here equals 3 . Okay, sorry, I'm just checking up on the group to see if everybody's still there. So we know that it landed on heads first. Alright? So the probability of it landing on heads in any order is 3 out of 4. 3 of the 4 outcomes have heads as at least one of the results. Okay? To throw a dice. Now this is another probability. You know that there are 6 numbers on a dice. So you know that you will hit one of those numbers from 1 to 6. So there are 6 possible outcomes when throwing a dice with 6 faces or sides. It can land on number 1, 2, 3, 4, 5 or 6. I'm sorry, I am distracted. The probability of landing on 1. Okay, so here we are.
Hi ma'am, we done this last year.
Okay, I've just been told that you've done this last year. So I'm not going to deal with this again then. So activity 28. And 29. And 30. So activity 28, 29 and 30 needs to be completed by second break. I'm going to go off now. I will see you guys a little bit later once you've done that. If you have any questions, you know where to find me. Goodbye, got to go, love you.